So in our notes for intersections and unions, we're going to go over that briefly. You already did the interval notation notes. That was yesterday. So today we're going to take what you learned there and we're going to apply it to this page. So before I do that, I want to kind of make a little note on the page. So I'm just going to do it in this top corner up here. And the messages are going to start with really the words and or. So the words and or. And represents intersections. So these represent intersections. So anytime you have an intersection, it's pretty much where you have two sets of data or two shaded regions that are going to overlap. So I'm going to put sets of items. So a set of items in both sets of data. That means that when you look at the graph, they're going to overlap. You're going to see one color. I'm going to use multiple colors for this. One color is going to overlap on top of the other. When you have the or terminology, so the or compound inequality, you're going to use a union. Union is kind of my favorite because it's kind of like the lazy way of doing things. This is when you have two different sets of data. You're pretty much going to combine everything together. So your set of items are in either answer set. So that means you're going to put everything as your answer. So everything as your answer. Okay, so let's look at example 6. So we're going to take the definitions that we just made and we're going to apply it to these questions. So in the notes from yesterday, or the video you should have watched yesterday, I told you guys how to write these in interval notation. Not necessarily with 2, but definitely with 1. So if I'm just looking at this one over here, how would I write this shaded region in interval notation? What would it look like? Yes, sir. Positive or negative?
It'd be negative. Negative infinity.
Uh-huh. You're good.
Comma. That's -3. That is negative. So that's -3 and then a bracket.
That's exactly it. So whenever you're writing these out, especially for a compound, because this is like a compound inequality, you're really just writing out two intervals. So Vincent helped me with the first one. I'm going to do the same thing for the second one here. So this one has an open circle. Vincent told me that I ended the other one with a bracket because it was closed. What do you represent with a open circle? A parentheses. So I'm going to put a parentheses, 1, and it's going to go to infinity. That's supposed to be an infinity symbol. So that's what I have. That's going to be for both of them. Let me ask you this. Is there any overlapping space? No, they're both going in two separate directions. So all I need to do in the middle of this is put a union. I'm going to put all of the graph in one big statement. So I'm going to put negative infinity to -3, union 1 to infinity. That's describing the entire graph. All right, let's look at the next one. For example 7, this one I would recommend graphing out. So I'm going to draw a number line. And I'm going to represent my numbers. So I have 8 and -6. We'll put -6 here, +8 here. 0 will be somewhere in the middle. You don't have to put 0, but I like to give you guys an idea of where 0 is on your number line. It doesn't have to be perfect. You don't have to put all the different hashes to get to -6 and +8. Okay, from here, I'm going to graph the first one. So x is less than 8. Okay, well, if x is less than 8, I'm going to put a circle at 8. What type of circle?
Open.
Does it stay open, or you guys are just saying it?
No.
It's definitely open. This is the less than symbol, so it stays open. And if x is less than 8, you're going to graph all of this space over here to the left. All of that space is less than 8. And then for the other one, we're going to have x is greater than 6. So for x is greater than 6, let's use pink. I'm going to do -6. I have an open circle because it's another greater than symbol. and I'm going to graph all of this space over here to the right-hand side. When you see the word and, like we said before, you're looking for an intersection, which means both of the colors that you have need to overlap. So if I was to put the pink and blue lines right on top of each other, where would they overlap? Where would they intersect? Between what two numbers? -6 and 8. So between -6 and +8. Notice that this one has an open circle and this one also has an open circle. Anytime you see open circles like this and you're doing the intersection, you're going to keep the parentheses around both of those numbers. The reason why, even though the blue line is going towards infinity, it technically is including -6 on this blue line, but the pink line isn't. So if the pink line is not including -6, you can't use it. Same thing applies for 8. Even though the pink line includes 8 for its set note or its values, you can't use it for the blue one. It won't work. All right, let's look at number 8. For number 8, I'm going to do the same thing. I like to graph these out so you can see what you're doing. Vincent, did you have a question?
Yes. Said that it cannot be the infinity symbol because it not. If the circles are filled in, would it just be infinity from infinity?
No. So if these two circles were filled in, it would still be 6 and 8, but you would have brackets around them because you would be including those values. Is that okay? Good question. All right, for this one here, I'm going to write out my values, 3, 6, 0, and 4. Okay, I'm going to put them on here. They're all positive. I will not take off points if you guys just put these in this type of order. I just want to make sure all the positives are on the correct side and the negatives are on the correct side. So far, this is fine. Okay, for the first one, 3, 6, I'm going to start at 3 with an open circle, and this one's going to go over to 6, which is another open circle. That's the first piece of data. I'm going to union that because this little symbol here, the big U, is for union. I'm going to union that with 0 to 4. So in pink, I'm going to use 0 to 4. 0 is included. 4 is not because it's open. Based on the definition I gave you guys earlier, when you're doing the union, you're going to include everything for your answer. So it's a set of items in either set. So it's going to be all of the items in the pink set and the blue set. So how would you write your answer for that? Vincent? That's exactly it. That's all you're doing. For unions, you include everything, all of the stuff that you have for your answer. For the intersections, you have to be very careful. You have to only see where they overlap. Some students are probably looking at this saying, wait, Ms. Tapia, you didn't allow us to do that for the last question. We had to put the parentheses around 6 and 8. You're absolutely right. The reason why is because we were doing an intersection. That's and. Since this one is a union, you're including all of these values, which include 3, and all of these values, which include 4. So you're including every single value on this. Let's do the same thing. I want you to see what this looks like as an intersection instead. So intersection is this symbol here. The upside down U is the intersection. That's an intersection. There is an I there, it's just very small. Just like before, I'm going to graph this out. I'm going to use 0, 3, 4, and 6. Literally the exact same. So from 3 to 6, we're going to put open circles. And from 0 to 4, we're going to put closed, then open. I have a bad habit of going super fast through notes to where I lose students. If you don't understand what I'm doing and I'm moving too fast, just raise your hand and I'll slow down. Okay, intersection is different. You want to see where the pink and blue line overlap. So where are they going to be right on top of each other? 2 of the same lines. What interval will that be between? 3 and 4. Okay, that's true. Between 3 and 4. But should I put parentheses around both? Brackets around both? What should I put? Parentheses around both. Reason why is because you cannot include 3 if it's an open circle. So especially since it's an intersection, you cannot include it. Same thing with the 4. All right, pretty simple. I'm going to do number 10. You guys are going to try number 11 in just a second. So for number 10, all right, I'm going to make a big number line. We're going to have quite a few things that we're going to draw on here. I'm going to have the numbers -10, 8, 5, and 10. Okay, so let me put -10, 0, and 10. Put 5 here and 8 here. I just want to give you a visual on what's going on. Even though this is written as a compound inequality on the far left between, or -10 is less than x, which is less than or equal to 8, you can also write this as an inequality or as interval notation. We did that on your video notes last time. So if I was to graph between -10 and 8, I'm going to put an open circle at -10. Does it stay open or should I close it? Stays open, and then I'm going to have an open circle at 8 too, right? What is it? Close. Since it's the less than or equal to symbol, close it. Then I'm just going to connect all of this. And then for the second one, I have 5 is less than x, which is less than or equal to 10. Okay, so at +5, we're going to do another open circle. +10, a closed circle. And I'm going to connect both of these. This is asking OR. Okay, OR represents a union, which means you're going to write your interval for everything in this problem. So what do you think the interval is going to be between what and what? -10 and 10. And -10 all the way over here is an open circle. -10 over here is a closed circle. So be careful with your signs or your symbols. Try example 11 right now. Try example 11 right now. So between 5 and 9, you should have closed circles. And then between -7 and 5, you should have closed circles for these also. This problem is asking for the intersection, and represents the intersection. Where do these intersect? Is there any other numbers or just 5? Just 5. So for this one, I just put one number, which is 5. You don't really need to put brackets around it because it's understood that there's only one answer. I don't know if I'll always put the little set squigglies around it or if I'll just put 5, but I wanted to give you guys just that a visual to see what it could look like on tests and quizzes, but we all know it should be just 5. I want to pose you guys another question though, because that one was a little tricky. Let's say I had almost the exact same setup, and you can literally do this right underneath what I'm doing. So this is like kind of a second example to this one. I'm going to keep almost the exact same intervals, but I'm going to change one little thing. I'm going to change one little thing. It's pretty much almost the exact same as example 11. I just changed one little thing. What do you mean parentheses? It's a less than now. So
We just have no answer.
well, let's see. Let's graph it out. That's what I want you guys to see. If I change that one piece, because right now it's just one number, is that going to change my answer? Do I have more of a set? Let's see what it does. So graph this out with me. And it's pretty much going to be the same intervals, 5 to 9. Okay, those are still closed circles. And then -7 to 5. 5 is now open on this. If I asked you to tell me where both of these intersect, and we put the pink line on top of the blue line, is there an intersection? Why not, Desiree?
Because open circle means that the 5 isn't included.
And
Don't intersect there anymore.
exactly, that's exactly it. Since that circle became open, once I put that pink line on top of the blue one, it no longer intersects at 5 because open circles mean they're not included values. So since they're not an included value, there would be no solution here. And I could write out no solution, but it's easier to put the 0 with the line through it. That means no solution. There is no possible intersection for this graph. So if I just change that one little sign, the whole problem is completely different. Keep that in mind, especially when you're doing intersections. All right, let's look at the last question that we're going to look at. Example 12. I will tell you for example 12, and I think honestly, y'all can do this one on your own. This first set, so this first squiggly bracket that we have, this is one problem that you need to solve first. Then solve this one, that's second. And then once you find the answer for both of these, do the intersection. So it's like 3 parts. Part 1, find the union for just this first part, right over here. Then find the intersection for this part. And then once you get these 2 answers, find the intersection for both. So start it off with at least this left-hand side first. So you should have probably about 3 graphs for this one. So the least you can do right now, this side right here. And there should be, by the way, look up for a second, there should be a parentheses around this negative infinity. You don't really need it, but just know that it should be there. All right, go. I'm giving you a minute head start.
Where it says put like infinities or
Yeah, so if infinities can work. So yeah, everything includes the infinities. That's what we had right up here. The very first question 6, we had it from negative infinity to 3. So you can include infinities. All right, so I have the first one up. So make sure yours looks like mine, and then I'll go through the second one too. This is just for the first one. This one is gonna go 5, 8, 16. Didn't mean to put the pink one at the bottom, but I'm making it work. Okay, so for these, for the inner, or for the union, for this first one, the union is everything. So this is going to go from -10 all the way to, this arrow means it's going to infinity. So we're going to make -10 to infinity. This is a parentheses, this is a bracket. That's the answer for the first big parentheses. I'm going to do the big intersection because I'm about to intersect the next answer once I get it. This one is an intersection. So you just want where both of these, the pink and blue, overlap. Again, I didn't have enough space to put the pink one on top, but the pink one is 5 to 16. Notice that the overlapping space is going to be from 5 to 8, bracket. Well, all you need to do from here is find the intersection for both of these now. So I'm going to make one last graph. We're going to have -10, we're going to have 5 and 8, and I'm going to graph this one out. So between -10 and infinity, we're going to have closed circle all the way to infinity. And then in pink, I'm going to have 5 to 8. So this is open circle, closed circle. If I'm looking for the intersection, where do both of these overlap? Between what two numbers? 5 and 8. It just so happens, this won't always happen, but it just so happens to be the exact same as the last answer. The class practice problems, these are just extra practice. If you have time later on before your tests and quizzes, this is going to help you with studying. So that way you have fresh questions to look at. No, the 5 should be a parentheses. Good catch. That's a parentheses. Thank you. Any other questions? All right, beautiful.